Many of the calculations you perform in MATLAB will use single values. However, there will be times when you want to define a range of values, such as the odd numbers from 11 to 19, or the powers of 10. In this movie, I will show you how to create those ranges in your script. I have started MATLAB, and I'm using a blank command window. Let's say that you want to create a range that just goes up by 1, which is the standard increment for this type of operation. I'll assign them to variable a, and I'll say it equals 3:7. And when I press enter, you see that MATLAB creates the values 3, 4, 5, 6, and 7. And if you're using the default installation for MATLAB, then you probably have the workspace at the bottom left corner, and you can see that variable a is a 1 by 5, which means a 1-row, 5-column array. And the values are 3, 4, 5, 6, and 7 enclosed in square brackets. That's how you go up by 1. You can also set a step value using a second argument. So I'll assign that to a variable called b, then an equal sign, and we'll start with 3, then a colon, and I want my step value to be 3. So I want the sequence to go up by 3. So 3:3:15. So what I should get are numbers going from 3 to 15 in increments of 3. And when I press enter, that's exactly what I get: 3, 6, 9, 12, and 15. If I were to go one less at my top value, so instead of 15, make it 14, so I'll do C equals, and then 3:3:, everything's the same so far, then 14 and press enter, then I only get 3, 6, 9, and 12. The reason for the difference is that MATLAB cannot go up to the next increment of 3, so it stops at 12, which is less than or equal to 14. Your step value can be negative. Let's say that I want to create a variable called d and assign it the values from 20 to 4, going down in increments of 4. So I'd start with 20, then a colon, then -4, colon, and take it down to 4. And when I press enter, I get 20, 16, 12, 8, and 4, as I anticipated. You can also create a linearly spaced vector, and that means that however many values you want to put into your vector, MATLAB will calculate them so that they are spread evenly between the beginning value and the ending value. I'll call this LINS for linear variables, although you can use any variable name you want, and I'll create it using the function linspace. And again, that is linearly spaced variables. Then a left parentheses, and then I'll start at 7, then a comma. Then I will end at 35, and then a comma. And now I can indicate how many values I want, and that'll be 5. Type a right parentheses and enter, and I get 7, 14, 21, 28, and 35. And you can see that I have 1, 2, 3, 4, 5 values in this linear space. You can do the same thing logarithmically, that is with powers of 10. That uses the log space function. I'll create a variable to contain the output that I'll call LOGSP equal, and the function is log space, like linspace, but for logarithmic values, LOGSPACE, left parentheses, and then I'll type a 1, a comma, and then a 5, which indicates the top end of the values, in this case a power of 10, then a comma, and the number of values I want, which is 5. Type a right parentheses and enter, and you see I get 10, 100, 1,000, 10,000, and 100,000. So 10 to the first, all the way up to 10 to the fifth. And as with strings, you can concatenate two values together into another variable. So if I create a variable called e, type an equal sign, and then a left square bracket, and type C space D, then a right square bracket and enter, then I get 3, 6, 9, 12, and then 20, 16, 12, 8, and 4. So as you can see, defining ranges of values is fairly straightforward. When you work with matrices or arrays, where you need a range of values, perhaps for testing, or perhaps the values that you're using follow a known pattern, the techniques that you've seen here will come in very handy.